data with WC save plot, and then another pause block inside a while loop is the standard structure that you need for being able to correctly save data using WinCon. More details about this can be found in the WinCon manual, so if you want it you can go and look that up. Okay, so what we do is your data comes from WinCon when you use the WC save plot command, and so we make a file name first using strcat in MATLAB. We just make a string out of the frequencies and amplitudes, and then we give it a .mat extension because that is the standard file extension for workspace files in MATLAB. What it enables us to do is, if you have this for loop structure ready, then for almost every lab you can just make a frequency vector or make an amplitude vector and just run it and have a piece of code for getting the data, and then you have another piece of code which runs the same loop, and only this time you load the data and then you calculate it, so it gets easier. The WC_stop command stops your lab from running, which is the Simulink model, and this process repeats 45 times and you get 45 files. So we will now go ahead and run this.
Yep.
Okay, so now that I'm going to hit run over here, the buffer and the axis are already set. Let's see what it does. Okay, so before we go ahead and run this, I must tell you something about the save plot command. Please note the peculiar formatting or the peculiar input requirements of the save plot command. It takes your plot name and your file name. File name is in the response variable which we got from the strcat command, but if you note the plot name, it is scope space dash space lab0/tag. That comes from the title bar of this window. WinCon is a bit picky about things, and if you do not match this title in any way, if you miss out a space, if you miss out a capital letter, your data will never be saved, and it can be a pretty hard and stupid problem to debug, so please pay attention to this. Okay, now we go ahead and run our code, and initially it appears like it's a flat line on the screen, but that is because our amplitude is so small that it's in the dead zone. So we let this piece of code run for the 45 loops and let it collect data. Another thing worth mentioning is the reason we used the stop time as 4 divided by frequency is because later on in this lab we are going to use a function called sine fit, which fits a sine wave to your noisy and bad data that you get. And in order for that to work, you must have at least 2 complete cycles. So 4 divided by frequency gives us 4 complete cycles, which is like a safe number of cycles to have just in case.
The more.
You can also see that although the plot shows no big deal of data, but the motor does have really small movements which is due to the small amplitude signal that's going into it right now. Now you can see we have a bigger amount of data. I guess we did not set the buffer long enough, but that's okay. Just so you know, this is an example. Your buffer size should be equal to, like, since we have the stop time as 4 divided by frequency, so we want 4 cycles, so your buffer time should be at least more than 4 times the frequency in hertz. So if your frequency is, like, say 1/10 of a second or 1/10 hertz, then your period will be 10 and you need 4 times that, so your buffer will be 40. The problem with having a small buffer is only the amount of data that overshoots the buffer is the amount that will be saved. So, like in the previous case, you had just half a cycle of data that was actually saved, which is bad for calculations. Now see the frequency increasing. This is the case for the last amplitude, which is 4. In case some of you noticed that the input sine wave is a sine wave signal with an amplitude 4 and some frequency, but obviously the peak-to-peak amplitude, as we see from the screen here, is closer to 6 or maybe even more. So to some of you it might occur why this happens, and the only reason for this lab, or typically the mechatronics class, is to be able to control and characterize uncertain systems. And this plot is proof that systems don't always behave the way you want them to behave. Ideally, a 4 and amplitudes of 4, peak to peak, sine wave should have just come out as 4, but clearly it is having a gain of some sort. This is typically what you do in system ID, which you are currently doing, getting the frequency response of the system. To understand how its gain varies or how its phase varies over different frequencies.